Any worries about that? Should be recording now. So thanks everyone for coming. There are docs in the calendar invite and in the chat channel here. These are our internal Holy Cross docs here. Note that the troubleshooting worksheet is also pinned in the outages channel in our Zoom. If you're in outages and you look at the top, there's incident response process. If you open that up, you'll see where that worksheet is there as well. That's a lot of what we're gonna be talking about here today. So talking about troubleshooting, one of the things I want to touch upon first here is sort of the scope for today's talk. I'm not going to get into escalations, not going to talk about what team does what, who to ask for this or that. Not talking about any of the operational side of troubleshooting. Really just want to talk about troubleshooting more in the abstract and how we can approach it systematically in a way that gets around a lot of common pitfalls. And while originally might look more process intensive, is actually going to save time in the long run. And at the end, we can talk about plenty of examples there where approaching it from a chaotic stance doesn't really save you the time in the end anyway. And an emphasis for sure on anyone can do this. So we've put together the documentation here to allow anyone in ITS to pick up that document and to face a challenge and a scenario where we don't know what's going on, and narrow down the scope of what's happening there and eventually figure out what's causing that problem. So I have 100% faith that literally anyone in the department can follow this process. That being said, our department, and I think we kind of drift away from this on occasion, but our department is a service delivery department. That's what we're here for. That's why we're at the college. We're not here to be developing products and things that we're selling. We're here to help the college sell its services to its clients. And 99% of those services are someone on a computer on the network doing something. That's what it's all about. That's our whole department, in a nutshell, is providing that service to our customers. So that being said, what is that service that we're providing? And one way to look at that holistically all at once is to look at what is the OSI model here. This is going to be the backbone of everything we're talking about today. OSI model, you may have heard people talk about this. You hear it bandied about. You probably say, what the hell is that? I have no clue what that even is. And this is what it is. It's just a model that talks about IT service delivery, and breaks that down into 7 different layers for each aspect of that. So like we talked about before, we're delivering a service to a person that's using a computer. That's it. And even with all the device proliferation today, they're all just little computers. So really all of this applies to all of those scenarios. There's maybe a 1% of fringe instances where, we're not providing exactly this, but this is for sure the bread and butter of what our department is doing and supporting. So this is ITS. If you were to consider it conceptually, this is what we're providing. We have people on computers that are going through a layer of software and physical connections and network connections to talk to servers that are doing the exact same thing and coming back and talking to us. This is it, man. This is what we do every single day. For our purposes, if you look up the OSI model on the internet, then you look at the exact definitions of the standard that was introduced, it's a little bit different than what we're going to talk about today. So we're using this and we're adapting the model to our needs and our specifications. But if you go out and look at it, yeah, it is slightly different in some of the layers and what some of those layers represent. So if you're going through this and you say, what the hell, Tim, that's not even what that layer is. We are taking a little bit of creative interpretation on some of these layers to help it fit our specific topology within our department a little bit better. So that's what I'm considering our department from a conceptual definition standpoint. What I'm considering troubleshooting within this talk and this model is really the act of finding a root cause by process of elimination. Something is broke. We're trying to figure out what broke. And we do that by eliminating not that, oh, could be that, you know, and sort of navigating that that landscape in that scenario. And I'm not talking about the actual problems here. Usually when you figure out the actual problem, that's the easy fix. You know, it's, oh, we got to add that data or turn off that feature or turn that server back on. Usually that's the easy part. The hard part is sort of navigating the scenario that you're presented with. Couple of golden principles that overarch the whole process here. Changes are really the root of a lot of these problems. Definitely when you're going through the process of elimination, you want to be attuned to, in each of these areas, has something changed that lines up? A lot of times there's a lot of change going on and not all those changes are going to line up. So just because it's timed and associated exactly with the problem, you do want to fight that urge that logically you got to follow the data there. So if you're faced with a lot of different changes, you got to be careful there. But generally speaking, that's a great overarching golden principle. Another one to really not get caught up on is in IT, we're talking about computers that are operating on ones and zeros and doing exactly what you tell them to do. Intermittent problems are really very rare, to the point where I would say that they probably don't exist truly. So if you're looking at something and it's presenting intermittently, chances are you don't fully have all the details there, or you're seeing something that's happening on a scheduled process and just not realizing it yet. Truly intermittent problems are very rare, type of thing. Another thing that's super rare is multiple causes. That's really rare too. There are times where you're troubleshooting a problem and you're really slamming your head against it, and it turns out to be two different causes. That can be really, really tricky because you're being presented with the symptoms of two different things mixed together. So if you're trying to do a process of elimination, that can be tricky, but it's very rare. It doesn't really happen. So when you're thinking about troubleshooting a large scale scenario that you don't know what's going on, assume you're looking for one thing. Don't get caught up on thinking that it could be multiple things there. And then of course, details. That's it, man. Can't do anything without details. So that's sort of a couple of golden principles there to set us up for what we're talking about. The other thing that we need to set up to even talk about using this layered approach is we need effective seed knowledge. This is the who, what, when, where, why. The more of those that you can answer, the better seeds that you're going to plant into that troubleshooting process. The fewer details you have planted into that troubleshooting process, the harder it's going to be, the less efficient it's going to be, and the more likely you are to not actually find the answer. So details, exact details. Error codes are gold. Exact pictures are gold. Exact environment details are gold. What's also gold and doesn't often come up is exactly what's been done so far. If someone's already eliminated half of the variables, that, man, is going to really change your layered approach to that troubleshooting. And another thing that has a lot of nuance is workaround. Workaround on face value is really more of a prioritization thing. You often hear it that, if there's a workaround, who cares? We'll get to it later. But more often than not, knowing what that workaround is going to tell you, it works that way, but it doesn't work the normal way. That's going to eliminate and focus your aperture a lot just by knowing what that workaround is and how it's being successful doing that. So, and then again, details, extremely verbose details. Too much detail is just the right amount of detail. That is the name of the game there. So that being said, how can we approach this using this model for assisting our troubleshooting here? So when we're talking about using the OSI model for troubleshooting, what we're talking about is really looking at each layer within that transport chain and saying, hey, could the problem be here? I don't know. How do we find out if the problem is there? So if you don't know what the layer is or what it's about, reference the worksheet. We've got seed questions on each of these layers to sort of guide how could you possibly figure out if that layer is the issue, and how would you eliminate it so that you can go and focus on a different layer where the issue might stand. If you don't have the worksheet or you don't have any clue, Google it. Google say, hey, what are common issues on layer 5 session layer of the OSI model that might be causing this problem to happen? It's as simple as that. Very, very straightforward. But what this really does is you have an outage, everyone's blood pressure hits 150, everyone's stressed out, and everyone starts just dumping information out in a very chaotic and unorganized way. And everyone at that point is looking at this chaos of information and trying to figure out what's happening here. Who's on first? What's on second? What's the root cause? That's not an efficient way to approach a large scale issue. At the same time, you have the proverbial client ready to whack you on the head. So that's what we're talking about here, is how can you use this model to change a stressful, chaotic situation into something that's efficient and systematic, and is going to lead you to the fastest possible resolution of the problem. So when in doubt, start at the top and just go through each layer of the model. And I do want to emphasize that while this looks like a checklist of top to bottom, really the most efficient approach is going to be to delegate out these layers all simultaneously. So you say, hey, so-and-so get me some information here, so-and-so give me some information here, we need more information there, and then come back and put all that information together at the same time. So it's not necessarily that you have to go one by one, each of these layers to each of the departments and rule them out. That's a lot slower of an approach. Human layer, this is not in the OSI model, but you'll often hear people talk about the proverbial layer 8 or layer 0. Here I like to call it layer 0 because really in a lot of ways this is the starting point of the whole thing. The who, what, when, where's, as many of those as you can answer are gold. Perfect details that we need. Screenshots, the way people describe things is never gonna be exactly what they're seeing. Language has error. People say things differently. People interpret what they're seeing differently. Screenshot is worth a 1,000 words for sure. This is also the layer where problem replication comes in and is super important. That's really going to be that part of that seed knowledge for the entire process is, can it be replicated? That's going to tell you so much about what layer the issue might be in. That's layer one. I'm gonna rifle through these, make sure we get through all these in time. Layer two, physical layer, the most often forgotten layer. This is right up there with, have you rebooted it? Is the cable plugged in? I've spent years working in tier one help desk, and I don't know how many calls I've gotten and the cable's not plugged in. It might look like it's plugged in. Unplug the damn thing and put it back in. So many times it solves a multitude of issues. But there's also deeper nuance to the physical layer. We are talking about electronic communications going between systems. That all goes over physical hardware. There's a whole bunch of things there that come out in nuanced ways. And that bleeds over a little bit into layer two, data link layer. And these first three layers are heavy network nerd territory. But it's the kind of thing that is worth stepping through because each of those has nuance in and of itself. So a data link layer, we're talking about how the computer is putting the information on the physical connections. In wireless, this is, the SSID. Can you see the wireless network? Does it come and go? Types of things. This is also the port speed. Ethernet runs on 3 wires. Most of the time not 3 wires, geez, 8 wires. Most of the time it's not even using all 8 wires. Sometimes one of those wires gets cranky, but the other 7 are okay. Playing with duplex can kind of tease out some of those physical layer issues there that can come into play here. Things like lights on the ports, this is part of that data link layer here. If you plug in the cable, does it have a light? Do you get a light that shows up on the device? Stuff like that is this layer here. So in this layer, think about it as VLANs. And VLANs are really just virtual LANs. And a LAN is just a bunch of things plugged into the same connecting network appliance. That's it. That's all it is. Back in the day, we'd have old school, you'd make a LAN on a table with a hub in the middle. That's all a VLAN is at the end of the day. The next layer in the network stack here specifically is layer 3. And this is where we get to IP addressing. So the IP address is what sits on top of the MAC address, and the MAC address is what sits on top of the physical connection to the network. Excuse me. So this is really that final tier in possible network issues here. And what we're talking about really is IP addresses, routing, connections at that IP level. So simple things to look for is, do you have an IP address? Does it come back with 169 or link local IP addresses that tell you that you might be connected and the light might be on, but you're not going to go anywhere because you can't route at the layer 3 level. Pings here. This is where you ping stuff. This is where gateways are important. When you do an IP config on a Windows device, show all, and you see what the gateway is. The gateway is your exit for that layer 3 network. Is it there? Can you ping it? Can you get to it? If you can't get to your exit point to get out to the larger network, you ain't going anywhere, type of thing. This is where also that proverbial question, is it working on campus and off campus and vice versa? This is what we're getting at here. If it works on campus, but not working off campus, tells you a lot about that layer 3 pathway that might be an issue. Layer 4, this is where we're taking a little bit of creative freedom here. For Holy Cross purposes, think about layer 4 as the network security layer, and everything that goes along with that. So, things like, have you logged off and logged back on? We do a lot of user ID level network mapping. If you're getting to the point where you think a specific service or a specific port might be blocked, this is where you get to that layer. So in the OSI model, transport layer is really talking about ports. Like you've heard of port 80 is HTTP traffic. That's how you browse the www. Port 443 is HTTPS. 90% of what a network security device is doing is blocking those specific ports. So the port is sitting on top of the IP address in that stack, and saying, okay, these IPs are trying to talk and they've agreed to talk on this specific port. So that's this layer is what we're talking about there. So certain things, hey, it works on HTTPS and doesn't work on HTTP. That's what we're talking about. Specific ports probably aren't working. So you can see how we're building up across that communication chain there. So session layer here, again, we're giving this a little bit of nuance here with a troubleshooting mindset. So think about this layer less as a network session is what it's originally intended for, but think of it more as a user session here. We're doing a lot of fancy user session things these days that involve cookies and tokens and timing and locations and passwords and usernames. This is a whole stack of things that can quickly get messy and impact the user's experience. So all the things there about incognito sessions, checking if you're logged into your personal Google versus your work Google, all that stuff comes into play here. Presentation layer. So here we're really thinking about the endpoint layer, operating system. What is the underlying software that's presenting the user with the software that they're trying to use? So here's where, you can think about OS patching, reboots, corrupt file system stuff, reimage, reinstall. This is that layer to think about what is serving up the software that the person is trying to use. And then sort of that final layer on top of that is, okay, we're plugged in, we're on the network, we're able to talk on the internet, we're on the correct ports, we're logged in and authenticated, but we're getting some kind of weirdo error, 501. What does this even mean? Now we're at the application layer here. So in most everything we're doing today, the application itself is being served as a software as a service, or it's communicating in the background the whole time to its phone home server. 90% of the applications we're talking about are fully on the network at the same time here. So this is where we're really looking for those specific browser errors, cache things. The internet browser today is a whole ecosystem of operating services in and of itself. Specific software dependencies, software versioning. Here's where tickets with the vendor, really come in with helping to eliminate a lot of things. And that's really the final layer in the stack. So we'd be collecting all that information and then plugging it in our checklist here. And if we check off a bunch of layers and we say, nah, this is clearly not this layer. We've eliminated a bunch of variables here. Then you eliminate the whole layer, check off the whole layer, cross it off, focus on a different one, move on to the next one. So we're going through that process of elimination there still throughout this whole thing. So when we're navigating that, this comes down to that anyone can do this. You still may need subject matter experts to help you answer some of these questions. That's why we have a department of nearly 60 people. There's a lot of subject matter experts across the team here. When you're thinking about these layers and thinking about questions to ask and details that are missing, think about the ones that are going to eliminate the most variables at once. That's why we ask things like, have you rebooted it? Does it work on campus versus off campus? We ask these questions because they're cutting out whole swaths of that stack, that communication transport. And we're saying, okay, well, we can just focus on these two layers here, and it's bound to be in one of these layers. Definitely want to parallel process that as much as you can, pull in specific SMEs, subject matter experts, ask them specific questions, give them specific things to check and come back and add to the record. And centrally have that record. This is Bethany's mantra here, ticket for everything. It's really hard to operate efficiently if you don't have that central record where everyone's putting the same information, everyone's looking at the same information at once. This is where that worksheet might help in certain instances because you're all looking at that same pane of glass and you're all agreeing that, yep, we're not looking at that anymore. We're looking at this now. And it gives a point for everyone to have that sort of collective focus there. So super quickly, I don't know if anyone's ever really thought, why is there the proverbial, have you tried turning it off and on again? The reason a reboot works so well is because it's reinitializing a ton of things within the OSI model all at once. You're eliminating a bunch of variables all with one step here. And the flip side of that coin is really a password reset. That eliminates everything from session layer, as well as some transport layer things all at once. Even application layer and presentation layer issues might come into that as well. So that's kind of the other half there, is we're talking about someone on a computer doing something. The big variables there are they're on a computer and it's someone. So that's really why reboots and password resets are the go-to first things to try, is because they are crossing so many layers at the same time. So thinking about that broad variable elimination, everything in ITS is done multiple ways for multiple reasons with different people. It's really a choose your own adventure game. But you can look at some of these scenarios here, and why they're so efficient when you're troubleshooting is because you're taking whole halves of that OSI model and eliminating it there. One device versus multiple devices. You hear this come up all the time. If it's one device, chances are it's a physical issue, a user issue, or something with the operating system. It's central to that. If it's multiple devices, it's not a physical issue or user issue or an operating system issue. It's probably 1, 2, 3, or 4, or possibly 7. That's why that question alone is hugely important. Problem replication, same kind of thought with that there as well. Timing, huge. We talked about timing and change chasing. Timing is huge for that. If you have something that you think is the cause of a time, a change that happened at a specific time, feed that into the process. Man, is it going to accelerate things when you can look at one specific thing and not a whole stack of things. A variation on this is, did it ever work, or is this a brand new request? Working in ITS for over a decade, I don't know how many times I've been presented with an issue only to find out that this is a service request. This isn't an incident. This thing never worked. Totally different approach to troubleshooting. So certainly really important bit of information there as well. And then so we're finally there. Types of error messages, lights, they're going to point you at different levels of that OSI model. So having those those pictures, those exact descriptions, super important because that's right away going to point you to different layers to work on and isolate there. Couple of closing thoughts. When in doubt, just start at the top, man. Run the list. Anything you can eliminate is going to be helpful there. If you run the list and you still aren't sure and you still can't solve the issue, double check. Chances are you missed something there. There's a lot of psychology that goes into troubleshooting. And this is something that everyone, including myself, deals with, where you think you looked at it and you think you checked everything and you think that it's not something there. If you're at the bottom and you still don't have the answer, go back and look. Chances are you missed something. There's a lot of psychology in there. Get someone else to look at it. If you're looking at the same thing day in, day out, every single time, it's really hard to notice something different. Get a second set of eyes. That is so helpful. Even a set of eyes that has no clue what they're looking at, they're going to ask different questions than you might ask. So part of that is really assuming that humility that maybe you looked and you missed it. Happens all the time. All the time. So you really want to confirm that you're eliminating layers on accurate information. Get screenshots. Don't be afraid to say, hey, let's get more eyes on it. Can someone show me what we're actually looking at? This comes up a lot with vendors and MSPs. It's okay to say, show me, screen share, show me, that's okay because it's the same layer 0 issues. Layer 0 applies to ITS as well. We're no different than the people we're serving at that level. If you do all that, great chance you're gonna see the problem. Really effective, powerful tool, industry standard, government standard. Everyone is using the same sort of approach to all this stuff. So I'm gonna stop and pause there and open it up to questions.